The final demo for the day is the startup called Newee, a startup from SAP Startup Studio, operating in the space of predictive analytics. Joining us today from Newee is Harsimrat Bhasin, the Chief Operations Officer and co-founder at Newee. Over to you, Harsimrat.
Thank you, Justin, and the SAP team for having us here today. Before I start off with my specific presentation, I just wanted to get into the context of why, in spite of having sensorization, manufacturing is probably way behind other industries in terms of digitalization. I mean, if you look at fintech, retail, they've made significant adoption in terms of digital technologies in terms of changing their operating and business models. But when you look at manufacturing, we're still not really have evolved to that stage. And we believe there are three reasons for it. The first one is that analytics is not integrated across the manufacturing value chain. And what do we mean by that? First, it's in silos in terms of supply chain exists on its own, manufacturing analytics in terms of OE analysis, etc., works on its own and in a separate isolation. Then you have things like asset analytics in terms of predictive and preventive maintenance, which works on its own. But the real value can be derived for manufacturers when this whole thing works end to end together for them. The second reason around this that we believe is that it's not something that impacts the person on the shop floor directly. So the person who's really doing the work, the blue collar worker, how is he guided by the intelligence that your analytics systems are giving out? How does he really take action in real time to act on what your analytics is telling us? Right now, it's mostly dedicated to the C-suite and the management layer. And third and last but not the least is that it's not at scale or it's not industrialized. And what we mean is that it doesn't exist across the entire system of manufacturing. So it just exists in parts, as in pilots, and in terms of how does that really impact somebody across the value chain. Now, what's the real answer for that? And we believe this is where Bodhi comes in. So primarily, how do we view manufacturing value chain? So for us, it's a set of interconnected processes that really work and interact together to deliver an outcome. So something that is happening at the beginning of the manufacturing process can really have a significant impact on something that gets delivered at the end. So the final product that gets created. And unless you really track and understand what has happened throughout the process, it's very difficult to be able to say, okay, what your end result would be. So how do we really approach this? We create what we call process digital twins, and everybody has heard of digital twins. But what we really mean by process digital twins is by integrating it across the entire manufacturing level. And we do it by integrating process information. So in terms of what are the manufacturing operations that take place across each work center where the work is happening, and how does that evolve? What are the product specifications evolution at each step of the manufacturing process, and then how does that evolve? So in terms of what are the tolerances, what is happening with the product as it's built out. Third is what is the assets of the equipment, jigs, tools, etc. that are being used at each step of the process, and how does that really impact the evolution of the product. The fourth is the work center characteristics itself in terms of what is the type of workforce that is deployed at each work center, or what are the skill levels, what's the seasonality around that. And then last but not least is what are your external factors. It could be in terms of supply chain related factors, raw material quality that is coming in, energy utilization, etc. Now, by integrating it across all of them through the entire value chain or through a line, you can really create a much more significant impact by than just looking at it in isolation. Because if you really look at it, most work centers these days operate at greater than 95% efficiency, probably close to 98, 99%. But then when you still see across at the end, you still have issues that creep in. And why is that? And we believe that we can eliminate those by looking at it across this thing. So with this, then we can give specific outcomes by defining clear, actionable predictions that can be used by the worker on the ground to do his job. And that is what we mean by a process digital twins. The most important thing is that we do it very, very quickly. I mean, we can implement it for fairly complex lines in a period of about 8 to 10 weeks. We've been able to do that even for as complex manufacturing processes as aerospace and aircraft manufacturing within that time frame, where there's thousands and thousands of operations that take place. What I'll do is I'll quickly walk you through two use cases on how this has been applied in specific context. The first one, which I will do, is for a fairly large automotive manufacturer out of India. We did this for their engine performance plan. And as you know, an engine manufacturing goes right through from the initial machining to assembly of the components. Then it goes through a cold test process and finally into hot test. And errors that creep in at time of machining and assembly essentially show up primarily at the end of hot test, and at that point of time it is fairly significant. What we're working with this manufacturer is to see how we can even eliminate the hot test process by being able to predict the outcome of what the outcome of the hot test would look like right through by looking at each step of this. What that gives the ability to the manufacturer is one is they can eliminate a fairly significant process, thus reducing cycle time. But more importantly, have significant predictability in terms of what is going to come out at the end of it. I mean, if you look at engines performance, they are very different across one vehicle to the other, although they go through the same entire manufacturing steps. We've already done this with a very high level of accuracy. We are able to predict engine performance with up to 95% accuracy and even do engine Caesar failure predictions with 91% accuracy right now. We're working towards how do we increase this further so that further we can move this process steps as further upstream as possible. The second use case that I'm going to present is around an electrical component manufacturer of a very large multinational. And what they really do is build circuit breakers, which are used. So they have production quantities that go up to 100,000 in their line. And the way the process works is there's manual steps of assembling this, but a lot of it is fairly automated and even to the extent of using robots, etc., to do a lot of the work that happens there. And the problem statement that we're working with there is how do we improve the first pass yield as the build out happens. So what we did was we did performance predictions and understanding of how each step of the process and where it happens impacts the ultimate outcome. And based on that, we've been able to demonstrate specific recommendations that could be passed on to the system, which would then allow it to really have a very significant impact on first pass yield. We've demonstrated this live on the line and are in the process of now extending this out across 7 of the lines across the plant that we work with. So with this, examples are the ones that I showed, but across the entire spectrum of customers that we work with, we've been able to deliver significant impact, right? From quality improvement or productivity improvement, cost reduction by reducing either cycle times or first pass yield or reducing non-conformances as they creep in through the system. We have strong customer credentials backing us. We work with the large names across Europe and in India. We've been recognized by analysts such as Forrester, and last year we had our initial funding round of $4 million by IFL. We're supported by a team of 50 people based across India and Europe. And our end goal is to make manufacturing more visible, transparent, efficient, and autonomous. Thank you.
Thank you, Harsimrat, for that insightful pitch. Predictive analytics is a critical piece in the construct of Industry 4.0 and the factories of the future. I'm sure this space is really gaining a lot of traction as we talk, and I'm sure this discussion would have certainly triggered a lot of questions in the mind of the audience right here. With that, we come to the end of the demo sessions, and please do share your questions for the demos that you have seen so far in the day. Our moderator will pick up these questions as part of the dedicated session, which is lined up right after this. We hope you enjoyed the day so far, and look forward to engaging with you soon. Thank you.